right, guys, Mr. Bouchard, back at it again. I request to talk more slowly this time. I don't think it's going to happen, unfortunately. I got to get this done. But, all right, so this is all about drawing geometric figures. So hopefully you guys have like some kind of combination of a protractor and a ruler, because we're going to do centimeters for everything. And then, be measuring angles here. Okay, so we got students in the art club designing a flag with the school's mascot and emblem. The flag has 4 sides. Oh, with 2 sides that are twice as long as the other 2 sides. What shape could the flag be, and what dimensions could it have? Make and label a scale drawing as part of your answer. Yeah, this crazy rooster guy. Anyway, okay, so 2 sides. It's basically a 4-sided figure, right? 2 sides are shorter than the other by half, right? So I'm going to do a flag that is 6 centimeters on one side. So you'll see my ruler right here is in centimeters. I'm not going to worry about inches because it's too big. It'll just go off the page. 6 centimeters right there. Okay, so I'm going to label that 6 centimeters. And then 2 sides are half that. So half of that would be 3. So you can see I'm doing 3 centimeters right there. And actually, I'm going to line this up. I'm going to make this a rectangle. So I'm going to use my protractor right here. When I get in, it's kind of interfering with the text right there, but you can see hopefully that it says 90 if I focus it up there. Okay, it says 90 right there. So I can just make a little dot right at the center to get it at 90 degrees. And now I'm going to make this 3 centimeters long because this side, remember, this side is twice as long as this side. So I just do that. And then I'll do another 90-degree angle over here. Okay, again, sorry it's interfering with the text. I probably could have moved it down, but hey, my bad. We're in it right now, so. Okay, oh gosh, flip this around so it's steadier. There we go. Okay, line it up. You'll see I'm lining it up on the bottom line right there. That's 90 right there, so I can just make it right at the thing right there. Okay, I'm gonna do 3 centimeters right there. Okay. Boom. And then I'm going to just connect those lines. Gosh, sorry about that, guys. Let me zero in on that. Just like so. Okay. And I've got this side as 6 centimeters. I've got this side as 3 centimeters. Gosh, I got to make sure I'm focusing this. Sorry. And then this side is double check, also 3 centimeters. Okay. Now, this is not the only option of shapes you could do. You could make like parallelograms. You could make kites, but I am crunched on time, so I'm going to move on. School's landscaping club is designing a 4-sided patio and garden. The patio has 2 perpendicular sides that measure 4 yards. The third side that is perpendicular to one of the sides but twice as long. One angle of the patio measures 135 degrees. Let's see if I got that on my. Yeah, shoot. There we go. Okay. So my suggestion is that you go down here because you'll have more room that way. So perpendicular, I don't know if you guys know that vocabulary word, that just means a right angle. Okay, so we have 2 perpendicular sides that measure 4 yards, and this third side, our scale is 1 centimeter to 1 yard. So I'm going to have 4 yards here. Okay, and then I'm going to make a 90-degree angle. Actually, I'm going to do it here. So 90-degree angle is going to go out like this way. Ooh, I want to set it up like that so I can actually draw it. So 90-degree angle is going to go out that way. Okay, you'll see it says kind of goes out to 90, and that's just that little dot is just a guide for me to draw this at 4 centimeters long. So right there. Okay. And I just measured it, so I know that this angle is 90 degrees. Okay. And then it also has another angle that's 90 degrees. So I could do it on this one or this one, but if I do it on this one, it's going to like make the shape go down here. So I want to kind of extend it up this way, right? So I'm going to make sure that this angle is 90 degrees as well. So I use my protractor to pop it right there. And then I go, so I know this is 90 degrees. And then it does say a third side that is perpendicular to one of the equal sides, but twice as long. So perpendicular to this side, but twice as long. So I'm going to go out to 8. Make sure I'm going through that. Boom, right there. And then I'll connect the sides here. Okay. I know that this is 90 degrees because I measured it. And then it does say one of the angles measures 135. And if we did this right, we should see that this angle measures 135 degrees. So I'm going to use this. Oh, that's pretty close. Let's see if I can get it. Oh, shoot. It's like dead on. Boom. Okay. See if I line it up here on the point, the protractor. I line this line on the protractor up with my line that I drew, and I go out to 135 degrees, directly between 130 and 140. So, boom. As long as you're getting your angles right, it should kind of force these conditions to be true. Let's see, two equal sides that meet at a right angle, and then two non-adjacent sides of the same measure. Now, just through having done this before, I know what shape this is going to be. Let's see, what's this going to be? It doesn't say what the measurements are, so I'm just going to say 3 centimeters here, and then at a 90-degree angle. That actually might push it off the page. I'm going to move it. I'm going to do 3 centimeters, but I'm going to do it. I'm going to do 2 centimeters actually here, and then I do a 90-degree angle off of that. I could get this up here. Okay. So I put that right there. Okay. And now I have this, and I did 2 centimeters. So I'm going to do a 2 centimeter out at 90 degrees right there. So since I measured it, I know that's 90 degrees. Okay. And then let's see, that meet at a right angle and two non-adjacent angles of the same measure. So, okay, I want to make this kind of like even Steven. So I want to go half of this, and I want the point on the other shape to be kind of half in the middle right here, because that's going to force these sides to be the same measurement. And so half of 90 is 45 degrees. So I will send out a line at 45 degrees, which is like right here, okay? Because it's like between 40 and 50 right there. And so what I want to happen is I want these two lines to kind of connect right there. So I'm just going to do that. And I'm going to connect them, and then hopefully they'll be the same length, okay? So we've got this, and let's see, two non-adjacent angles of the same measure that meet at a right angle. Yeah, that works. Okay, so that's going to be like almost 3, and that one's going to be almost 3 as well. So perfect. And let's check the measure here. To the meet at right angle, two non-adjacent angles of the same measure. So these guys are the non-adjacent angles. So let's double check the measurement here. That goes out to about 102, and then we'll double check this one as well. Actually, let's double check here. Did that hit 102, 104? And then this one should hopefully, if I got this right, yeah, that's about right. Boom, 104 out right there. Yeah, cool. Whew. All right. Mr. Miller's classroom has desks shaped like equilateral triangles. Equilateral just means all sides of the same measurements, which means that each angle is the same measurement as well. He's planning to arrange the desks for a lunch for 10 people. If one person can sit at each edge of each desk, how many desks does he need? So he basically kind of wants to put them all together like this. So there's 2 ways that I found to do this. So the first one uses 8 desks. We would set it up like this: 2, 3, 4, 5, 6, 7, 8. Because you can put a person here: 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would use 8 desks. Okay. The other way, because this is kind of like a weird way to have a conversation, right? The other way is to kind of like group them together more, and this actually uses a lot more desks. 1, 2, 3. You kind of make a little hexagon with the set of desks like this, right? But then you keep extending it out. So there, 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 there. So we've got 1, 2, 3, 4, 5, 6 so far, but we'll keep extending it, right? So this is going to go right here, right here, right here, And right here, you'll notice I have a little hexagon right here. So that's here and here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so we get 1, 2, 3, 4, 5, 6, 7. Is that right? 10 desks? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wow, that's more than I thought. Huh. 6 here, 10, 14. Dang. 14 desks, right? So you need more desks for that one, but it's probably better for conversation. Okay. An engineer makes a scale drawing of a floor of one building. The floor has two pairs of parallel sides that are 50 feet and 80 feet. Two of the four angles measure 60 degrees. Make a scale drawing. What's the name of the floor shape? So we got to figure out our scale here, and our scale is going to be 1 centimeter equals 10 feet. Okay. So I'm going to put the bottom line down here. I'd give yourself plenty of room to draw this. So kind of start at the bottom here. I'm going to go out to 8 centimeters here. Okay. And then I'm going to measure 60 degrees using my protractor, which is right about here. What's up, Cece? Go for it. Okay. So that's 60 degrees from right there. Excuse me. We want to make sure that this is 50 feet, so 5 centimeters. Excuse me. And I want to make sure it's on that 60-degree angle. So I go right there. Okay. So I know since I just measured that that's 5 centimeters and that's 8 centimeters. Okay. And then I want to draw that. I want to make sure that this is 60 degrees as well. So I'm going to go out right there. Okay. And again, I want this one to be 5 centimeters long and on that same angle. Boom. And then I'm going to count this, and that should be, if I got this right, maybe not perfect, but it's close to 8 centimeters. Right there. That's 5 centimeters. Now, this is called a parallelogram because it's got two sides that are parallel to each other. This side is parallel to that, meaning they will never touch, right there, like that. And then this side is parallel to that side. Whew, sorry if that was real fast, guys.